Hello, welcome back. The title of this lesson is called Dividing Decimals. This is part 1. So here we're going to have one decimal number divided by another decimal. We're going to have to explain how to handle the decimal points, how to carry out the long division, and also to interpret what the answer actually means. So let's just jump right into it by giving the following example. Let's say that we're trying to take 25.2 and we want to divide that by the number 1.8. Now, here's the thing that you really need to remember when dividing decimals. The number on the outside of the division house here, notice it has a 1.8 there. We really don't want to see any decimals on the outside of the division house. It just makes the division process easier if that decimal is gone. How can we get rid of it? I mean, the number already has a decimal in there. How can we just poof, make it disappear? Let me show you what to do. Then we're going to finish this problem. And then at the very end, I'm going to explain to you very clearly why doing this is okay to do. What we're going to do is we're going to take this problem, we're going to change it. We want to do this division, but what we're going to do is move the decimal point one spot to the right. But if we move it one spot to the right on the outside, then in order to keep the division problem the same, we must move the inside decimal point one place as well. As long as we move both numbers, decimal points in the same direction, then, and the same number of positions, then, even though we have a new problem, the answer to the problem will be the same. So for instance, we're not going to solve this problem. We are going to solve a different problem that's very similar. It'll be 18 on the outside, and on the inside, it'll be 2, 5, 2, right? Because what happens is, we have moved this decimal one spot to the right, so it's really 18 and an invisible decimal point here, and then we move this one spot to the right, which means it's really 252 with a kind of an invisible decimal point there, like this, right? And of course it's 0.0, right? So what we want to do then is wherever you see the decimal point under the house, you want to write the decimal point directly above. You almost put the decimal point in the answer like before you even do anything else. The decimal point we know for sure is going to go right there, right above the one we see in our problem. And the one we see in our problem is here because we moved it one spot to the right, and we did that because we moved them both. So let's get through the end of it, and I'll explain more of the details. So 18, can that go into 2? No, it can't. 2 is too small. 18, can it go into 25? Yes, it can. How many times? Well, it can only fit one time. If you multiply 18 times 2, you're going to find out that it's much larger than 25. I mean, if you think about it, this is close to 20, and then 20 times 2 is 40. That's way bigger than 25. So we say it only goes one time. Now we multiply. The rest of the process of division actually doesn't change. It's the same process that you already know. We have to take 25 and subtract 18. Now you can borrow if you want, or just start at 18 and count up. 19, 20, 21, 22, 23, 24, 25. That is a difference of 7. If you go over here and subtract and borrow, you're going to get an answer of 7. After we subtract, we always grab the next digit, which in this case is a 2. Now I have to ask myself, 18 times something is equal to 72, or at least as close as possible to 72 without going over. So I'm not really sure if it's going to be 18 times 2. I know it probably won't be because 20 times 2 is 40. It's probably bigger than that. 18 times 3, 18 times 4, not sure. So go over to the side and go ahead and work out 18 times 4. 8 times 4 is 32. And then this is 1 times 4 is 4, and then 5, 6, 7. So it actually equals exactly 72 when we multiply by 4. So 18 times 4 is exactly equal to 72, and now we have a difference of 0. There are no further digits to drag down in our problem, and the remainder is 0, so we can stop. When you get to a remainder of 0, or if there's no more digits to drag down, then you can go ahead and stop. All right, now, what do we learn from this? We're basically figured out that when you take 252 and divide it by 18, you get 14, and there's a decimal, and there's nothing here, which means 14.0. So you can kind of ignore the decimal and just say that the answer is 14. So for this particular problem, if you grab a calculator and take 25.2 and divide it by 1.8, you're going to get an exact answer of 14. It goes an exact whole number of times with no remainder. Because there's no remainder, there's no decimal there. It just goes a whole number of times. All right? And so that's what we're going to do for every problem. We're going to move the decimal so we don't have a decimal on the outside. Whatever we move the decimal on the outside, we must also move it on the inside. Now, I want to answer a question. People ask me, why can we move decimals like this? Well, let's think about what this means. 25.2 divided by 1.8. We can write that as a fraction. 25.2 on the top divided by 1.8. Because remember, anytime you write a fraction, it's the same thing as division. All fractions are division. So if I see a division problem, I can write it as a fraction. Now let me ask you a question. Can we have learned that we can multiply or divide fractions by anything we want to get an equivalent fraction. What if I choose to multiply this fraction by 10 on the top and then by 10 on the bottom? What am I going to get? Well, when you multiply any number times 10, it moves the decimal one position to the right. If you multiply by 100, it moves the decimal 2 times to the right. If you multiply by 1,000, it moves 3 times to the right. So when I multiply by 10, I get 252. And then if I multiply by 10 here, the decimal moves 1 spot to 18. But this thing is 252 divided by 18. What we're saying here is that the original problem, 25.2 divided by 1.8, if I multiply both of those numbers by 10, I get a new problem with a new division. But because these are equivalent fractions, we know that this division problem is exactly the same answer as whatever we get from this problem. So we don't want to deal with decimals on the outside of the division house. So we always move the decimal, but wherever we move it, however many spaces we move it, we must move the inner decimal point as well in order to keep the problem equivalent. That's what we're doing. And it all boils down to fractions. Everything comes back to fractions. All right, let's take a look at problem number 2. Let's say we have 3.15, and we're going to divide that by 0.7. But I don't want to solve this problem because I have a decimal there. So what do? I move the decimal 1 position to the right, and therefore I move this one position to the right also. Effectively, I've multiplied this one by 10, and I've also multiplied this one by 10. But the new problem I get will have the same answer as this one. So I now have a problem where it's a 7 on the outside and it's 31.5 on the inside. I moved it 1 spot and 1 spot. This is the new problem I'm actually going to solve. First step, you see where the decimal point is. Go ahead and put it right above it, float it right above there, and you will get, that's where the decimal will live in the final answer. Now let's proceed. Can 7 go into 3? No, it can't. Can 7 go into 31? Well, 7 times 4 is 28. 7 times 5 is 35. So it has to go 4 times. 7 times 4 is 28. Now you can borrow if you want, but it's a bunch of mess here because I have to make this an 11 and change that to a 2. Instead, just start at 28 and count up. 29, 30, 31. There's only a difference of 3 here. So 31 minus 28 is 3. After I do that, I always drag the next digit and bring it down for a 5. Now 7 times something is 35. Of course we know 7 times 5 is 35. And then we have a 0 remainder and we're done. We don't have any more digits to bring down. We have a 0 remainder, so we're finished. And the answer to this problem we can now see is exactly 4.5. So you can see as in the original problem, we got the answer and we got a whole number of 14. But that was more luck than anything else. Really, most of the time when you take a decimal and divide by another decimal, the answer you're going to get is also going to be, it's going to have a decimal in it. All right, let's move right along. Let's take a look at 14.49, and let's divide it by 2.1. But I don't want to solve this problem. I have a decimal out here, so what do? I move this decimal 1 position, and then therefore I must move this one 1 position as well in order to keep it to be the same. So really, this will look like a 21, and over here, under here, it'll be 144 with a decimal point here, 9. I move the decimal 1 spot and 1 spot. This is the new problem I'm going to solve. Now my decimal point is here, so I'm going to float the answer decimal point right above it, and then I'm going to start solving the problem. 21 cannot go into 1. 21 cannot go into 14. It's too small. 21 can go into 144. How many times? I actually don't know. Now, 21 cannot go into 1. 21 cannot go into 14. It's too small. 21 can go into 144. I'm not sure how many times. Let's just try 21 times 6. 6 times 1 is 6. 6 times 2 is 12. So 126, pretty close to 144. Let's just try 21 times 7. 7 times 1 is 7. 7 times 2 is 14. That's 147. That's a little bit too big. So it actually goes 6 times. And we just said that 21 times 6 is 126. 126. All right, so we have to subtract these. Now, you can count up if you want, but sometimes it's difficult to do that. So let's go ahead and take 144 and let's subtract 126. The 4 has to become a 14, and this has to be a 3 in order to borrow. And then 14 minus 6 is going to be 8. And then 3 minus 2 is 1. And then 1 minus 1 is 0. So really what we get here is an answer of 18. And so we have an 18 here. After we subtract, we grab the 9 and bring the next digit down. So 21 times something is as close to 189 as I can get. I'm not sure what it is. Let's just try 21 times 9 and see. 9 times 1 is 9, and 9 times 2 is 18. It turns out that that's exactly equal to 189, so it goes 9 times. And 9 times 21 is 189. And then we get a remainder of 0. There are no further digits to drag down with the remainder of 0. So the answer to this problem is 6.9. Just as we have written it right here, 6.9. All right, we are at the halfway point, making good progress. The process really just gets very, very reliable after a while. You just know exactly what to do. 1.5, and we're going to take the number 4.05, and we're going to divide it by 1.5. But again, I don't want to do this problem. I don't want this decimal point. I move it 1 spot over, so I must move this one spot over. So then I'm going to have 15 on the outside, and this number will become 40.5. This is the problem I'm going to solve. My decimal is here, so I put it right there in the answer. Now, 15 times something is 40. 15 times 2 is 30. And 15 times 3 is actually 45. That's too much. So it has to be times 2, which is 30. And then 40 minus 30 is 10. And after we subtract, we grab the next digit, which is now giving me a 105 down here. Now, 15 times something is 105. I'm not totally sure. I want to get as close as I can without going over. So let's try 15 times 7. 7 times 5 is 35. 7 times 1 is 7, 8, 9, 10. That's exactly equal to 105. If you happen to guess wrong, you just float around until you get as close as you can. In this case, it goes 7 times. We multiply it and get 105 and a remainder of 0. And we don't have any further digits to bring down. So the answer to this is 2.7. So you see the actual division process is really the same as you've already learned. Now this next problem will be a little bit different. Let's take a look at what it is. 0.22 on the outside, and on the inside is 6.93. Now, I don't want to solve this problem. I have a decimal point here. I want no decimals out here, so instead of moving it only one place, I'm going to move it 2 places. And if I do that, I must also move this one 2 places so that they match. That would be like taking remember we said we can write division as fractions. Let me go probably over here. That would be like taking 6.93 divided by 0.22, like this. And then we said we can multiply these fractions by anything we want. So let's multiply this by 100, and so this one will multiply by 100 as well. So if we multiply this one by 100, the decimal point moves 2 spots, and if we do it here, the decimal point will also move the 2 spots. That's why we're moving them on the outside and on the inside. So what we're going to have is this on the outside will become 22, and on the inside it'll become, we move the 2 times, it'll be 693 with a kind of an invisible decimal point here, so I can float it up in the answer if I'd like. Now, 22 times something is as close to 69 as possible. I'm not sure, but let's say 22 times 3. 2 times 3 is 6, 2 times 3 is 6, so 66 is as close as I'm going to get. So I have a 3 here. Multiply, I get 66. And 9 minus 6 is 3. So I have a leftover of 3, and I grab the next digit, which is also a 3. And then I ask myself, okay, how many times 22 times something can get as close to 33 as possible? Right? 1 time will give me 22, 2 times will be 44, that's too much. So a 1 goes here, I multiply times the 22 and subtract, I get a 1 right here and a 1 right here. Now here is where the problem departs a little bit from before. You see before, notice we stop the process when we have a 0 remainder and no other digits to bring down. A zero remainder, no other digits to bring down. A zero remainder with no other digits to bring down. But here when we subtracted, we did not get a zero. We don't have any other digits, but we did not get a zero remainder, so we cannot stop. See, after a decimal point, after this decimal point, there's a bunch of infinite zeros out here that we just don't write down. So whenever you have a remainder that's not zero, so we know we're not done, you can just add another zero after the decimal point. 693.0 is the same number as 693. So what we do is we add a zero that we can then bring down. And now we continue the process. We have to get as close as we can to 110. So 22. Let's try times 5. 2 times 5 is 10, carry the 1. 2 times 5 is 10. 1 more is 11. That's exactly what we're looking for, so it goes 5 times. 5 times 22 is 110, and now we have a remainder of 0 with no other digits to bring down. If we had gotten another remainder here that was different than 0, we could not stop. We would have to add another 0 and bring it down. So when you're dividing decimals, if you ever have a remainder that's not 0, then you just have to keep adding zeros after the decimal and keep dragging them down until you get to a point where the remainder is 0. Or if you start seeing that the decimal pattern keeps repeating over and over and over again, which we will get to in a future lesson, but if it starts repeating, then maybe your decimal never ever stops, and then you can kind of see the pattern. But for these problems, we see that it stops. We've added a digit here. We see that it stops, and so the answer here is 31.5, which is 31.5. So you want to go until you see that remainder a 0, and we can add zeros after the decimal if we need to. All right, here's our very last problem. Let's take a look at the number 1.8, and we want to divide it by 0.08. So we need a decimal point that's gone here, so we move it 2 positions. So we move this one. We don't have another position. So you have to insert another 0 and move the decimal right there. You might say, how can you do that? It's because the decimal 1.8 is the same as the decimal 1.80, but that's the same as 1.800, same as 1.8000000. You can add as many zeros after a decimal point as you want. It doesn't change anything. So when we needed to jump 2 positions, we just had to insert one of these to make it work out. Now, on the outside, we're going to have an 8, and on the inside, what are we going to have? 180, because we moved it right here. There's an invisible decimal point there, so we just float it up above. Now we have to do this problem. All right. 8 going into 18. 8 times 2 is 16. 8 times 3 is 24. That's too much. So it has to be 8 times 2 for 16. Subtract and get a 2. After we subtract, grab the 0, and now we have 20. Again, 8 times 2 is 16. 8 times 3 is 24. That's too much. So it has to go 2 times. 8 times 2, 16, subtract. You can borrow if you want, but if you count up from 16, you have 17, 18, 19, 20. The difference is 4. So we did not get a remainder of 0. We do not have any more digits to drag down. So what we do in that case is what we did in the last lesson. We have to add our own 0 to then bring down, and now we have a 40 here. So 8 times 5 is 40, so 5 goes here, and we multiply, subtract, and now we get a remainder of 0, and there are no other digits to drag down, so we know we're done. And we get an answer of 22.5, or 22.5 exactly. So here we've conquered the topic of dividing decimals. The big thing you have to remember is that the decimal point on the outside of the division symbol, we don't want a decimal there. So if we have to move the decimal position on the outside, then we also must move the decimal position on the inside by the exact same number of places. Now, a lot of students, again, wonder how you can do that. How can you just change the problem? It's because this can be written as a fraction, 25.2 divided by 1.8. And we can change any fraction by multiplying by whatever we want. So if we multiply by 10, we move the decimal places of both one position, and this division problem is going to be the exact same answer once I calculate it as this one. So we choose to solve that one. So if you move the decimal 1 spot on the outside, you must move it 1 spot on the inside. If you move the decimal spot 5 places on the outside, you must move it 5 places on the inside. After that, you really proceed as usual. The only other real gotcha is that you're always looking for the remainder to be 0. If you ever get to a place where it's not 0, then you need to keep adding zeros after the decimal and keep dragging them down, trying to get to a remainder of 0. You're going to stop the process either when you get a remainder of 0, which is what you're trying to do, or if you start seeing the decimal pattern repeat over and over and over and over again, then you would know you can stop also. For instance, maybe you get an answer like 3.2525252525. Then eventually you could just stop and say that the 25 repeats forever. But in that case, that's a little different than what we're doing here. But that's the other case you would look for. I'd like you to practice all of these and then follow me on to part 2. We will continue practicing how to divide decimals.